This is chapter 20, the third part. From exercise 20b, question number 11. This is to do with cones. A right circular cone of height 20 centimeter and base diameter 30 centimeter is casted into smaller cones of equal sizes with base radius 10 centimeter and height 9 centimeter. Find how many small cones are made. If you read from the beginning, it says a right circular cone, a cone, this is the cone, of height 20 centimeter. Height of this cone I have considered as capital H is 20 centimeter and base diameter 30 centimeter. Diameter is given, this whole length, diameter D is 30 centimeter, but we don't need the diameter, we need the radius. Radius is half of the diameter, therefore radius I have considered as capital R, which is half of 30, that's 15 centimeter. This cone is casted into smaller cones. This is melted and made into smaller cones like this. Okay. So casted into smaller cones of equal size. All these cones are of equal size. With base radius of these cones is 10 centimeter and height is 9. Height of this cone, all these cones are 9 centimeter. Okay. Find how many small cones are made. How many such small cones can be made? I don't know how many, that's why I've just drawn 3 of them and put dots. I don't know how many are there. Okay. So the first thing that you have to consider is, this is melted and made into these small cones. Now you don't know how many small cones are going to be made. Therefore, the first assumption is, let the number of small cones, which you are going to make to be x. Okay. So this is melted and made into x number of small cones. Okay. So the relationship here is the volume of this big cone must be equal to volume of all these x small cones which you are making. So the relationship now is volume of big cone, that is this one, should be equal to, don't write volume of x small cones, write the x first, x into volume of small cone. Okay. Volume of big cone is equal to x times volume of each of this small cone. And then substitute by the formula. Volume of big cone. Volume of cone formula is 1 by 3 pi r squared h. So 1 by 3 pi, radius here is capital R, so r squared into height is capital H, is equal to x into, again volume of cone. Volume of cone formula is 1 by 3 pi r squared h. So 1 by 3 pi, now r here is small r squared into h is small h. See what you can cancel on both sides. Okay. You can cancel the 1 by 3 on both sides. You can cancel pi on both sides. Okay. And then substitute the rest. Capital R squared. Capital R is 15, so 15 twice here, right? 15 into 15 into height of this is 20 is equal to x is still there into small r is 10, so r squared will be 10 into 10 into small h is 9. X is what you are going to find. This is what you are going to find. So bring these numbers to the other side. Okay. So you will get 15 into 15 into 20. And the 10, 10 and 9 comes to the left side. So divided by 10 into 10 into 9 will give you the value of x. To simplify this, see what all you can cancel. So this 0 and this 0 is gone. Okay. 2 and 10 goes 5 times. 5 and 15 goes thrice. 3 and 9 goes thrice. 3 and 15 goes thrice. So all that, 5 times, sorry. So all that is left is 5. So x value are 5 cones. X is the number of cones that you assume. So there are 5 cones. So the number of small cones that are made are 5. That's the first question. Next one. This is from the same exercise. Question number 13. The floor area of a tent in the form of a right circular cone. There is a tent which is made, it's in the form of a cone. So the floor area of the tent in the form of a right circular cone is 3168 by 7 meters square. The floor area, if you assume a conical tent, the floor is in the shape of a circle. So the area of the floor is given as 3168 by 7 meters square. The canvas required for the tent is 3960 by 7 meters square. Now if you are using canvas is the material for making tents. The canvas that will be used will be the curved surface area of the cone, the circular area of the cone. Okay, you don't need the canvas for the base. Okay, you need the canvas only for the circular portion. Okay. So that canvas which is required is 3960 by 7 meters square. Question is, find the air capacity of the tent. Air capacity. How much air you can fill inside that tent. Air capacity is actually the volume. So you have to find the volume. So let's start with whatever is known. The first thing that you have to know is the floor area of the tent is so much. Floor area, as I said, floor of the tent, okay, which is a cone, is in the shape of a circle, which means this is the area of a circle. I'll just draw and show you. See this. If this is your tent, this is the floor area, which is a circle, and this portion is where you will use the canvas to make the tent, which is the curved surface area. So first case, you know the floor area. So area of the floor is actually area of a circle. So area of floor is equal to area of circle, and the area of floor given is 3168 by 7 is equal to area of circle formula is pi r squared. So 3168 by 7 is equal to pi value is 22 by 7 into r is what you are going to find. So r squared remains as it is. So see what all you can cancel. You can cancel the 7 and 7 on both sides. 22 and this will go 144 times. So you are left with r squared is equal to 144. R squared is 144. Which means if you have to find r, you have to find square root of 144. Square root of 144 is 12. So radius becomes 12 meter. The radius of this from here to here is 12 meter. Okay. The second thing that you know is known is the canvas required for the tent is so much. Canvas required, that is this portion, okay, which is called the curved surface area, is 3960 by 7 meters square. So let's go to that calculation. So area of canvas is actually the curved surface area of the cone, only this much. Okay, that's the curved surface area of the cone. So area of canvas you know is 3960 by 7 is equal to curved surface area of cone formula is pi r l. Pi is a constant, r is the radius of the base of the cone, and L stands for slant height, this one. Okay. So 3960 by 7, the same thing, is equal to pi value is 22 by 7 into radius you formed just now, that is 12, into L is what you can find here. Okay. So if you simplify this, you will get 15 meter is the value of L, which is the slant height, this one. So see what all you know in the cone. You found in the first case the radius. So this is the radius, which is 12 meter. And in this case you found the slant height, which is 15 meter. This one is 15 meter. And if you see there is a right angle triangle here. This is slant height, this is radius, and this is the perpendicular height or vertical height, which is small h. Okay. Because this is the right angle triangle, hypotenuse squared must be equal to perpendicular squared plus base squared. So I am using Pythagoras theorem now. According to Pythagoras theorem, hypotenuse squared is perpendicular squared plus base squared. Hypotenuse is this, which is L value, which is 15 squared is equal to perpendicular is this, which is 8 squared plus base is this. So that's 12 squared. Bring the 12 squared to the left hand side. 15 squared minus 12 squared is 8 squared. This is in the form a squared minus b squared, which can be written as a plus b into a minus b. That's our next step. a plus b into a minus b is equal to h square. Add these two, that will give you 27. Subtract these two, that will give you 3 is equal to h square. So if you have to find height, you have to find square root of this. So square root of this 27 can be written as 3 into 3 into 3, and this 3 is here. Now pair them up. That's one pair, that's the other pair. After finding square root, this will become 3, this will become 3. 3 into 3 gives you 9 meter is the height of the cone. It's the vertical line. But the actual question was to find the air capacity. As I said, air capacity is actually the volume. So volume of the cone, which is also called the air capacity. Volume formula is 1 by 3 pi r squared h. Okay. If you substitute all the values, that's 1 by 3, pi is 22 by 7 into radius, r value is 12, twice you have right into 12 into height is 9 is what we found just now. Okay. If you simplify this, you will get 9504 by 7. Write this as a mixed fraction. As a mixed fraction, it is 13575 by 7 meter cube, because you are finding volume. Volume is always measured in cubes. So meter cube is the capacity of this cone. The next question is question number 16. A rectangular vessel is 20 centimeter by 16 centimeter by 11 centimeter and is full of water. The water is poured into a conical vessel of base radius 10 centimeter. If the vessel is completely filled, find the height of the vessel. Let's go back to the question again. A rectangular vessel. A rectangular vessel means a vessel in the shape of a cuboid. This is the rectangular vessel which we are talking about. It's in the form of a cuboid which has length, breadth and height. First value is always length. So length is 20, breadth is 16 and height is 11. Length I have considered as capital L, breadth is capital B and height is capital H. This vessel is completely filled with water. It's full of water, it says. It's completely filled with water. The water is poured into a conical vessel. So there is a conical vessel. Okay, a cone. This water is transferred into this conical vessel. Okay. So the water is poured into a conical vessel of base radius 10 centimeter. Radius of this base is 10 centimeter, which I considered as smaller. If the vessel is completely filled, find the height of the vessel. You have to find the height of the vessel. Whatever water was here is completely filled into this cone. So volume of water here is same as the volume of water here. So the relationship between these two figures is volume of the cuboid must be equal to volume of the cone, because whatever water was here is filled in this cone. Therefore, their volume should be same. So, our relationship is volume of the cuboid is equal to volume of the cone. Substitute by the formula. Volume of cuboid is length into breadth into height. Length into breadth into height is equal to volume of cone. Formula is 1 by 3 pi r squared h. Put the values. L is 20 into breadth is 16 into height is 11 is equal to 1 by 3 pi value is 22 by 7 into r value is 10 into 10 into height is what you have to find. So h. Keep the h here and bring all these numbers to this side. So 20 into 16 into 11 into 3 into 7 divided by 22 into 10 into 10. That's what is here. That will give you the height. So if you simplify this, if you simplify all these, you will get 33.6 centimeter is the height of the cone. Therefore, the height of the conical vessel is 33.6 centimeter. And your homework from exercise 20B, question numbers 9, 14, 15 and 23.